Hello, welcome back. I'm going to give the answers to the practice and challenge problem. So I'm going to start by looking at how many terms we have. We have 3 separate terms. We have 4t and positive 3 and negative t. I'm going to start with my variable terms 1, 2, 3, 4t plus 3, 1, 2, 3, and a negative t, or the opposite of t, and I'm going to represent it like that. So I have 1, 2, 3, 4t. I've got positive 3, and then I have negative t, or the opposite of t. The only thing I can do here, the absolute only thing I can do here is make a 0 pair with my t's. So I'm going to make that 0 pair and get rid of them. That looks like this here, and you can see what I'm left with is 3t plus 3. 3t and 3. Okay. For f, I'm going to start with my terms, see how many I have. And I'm going to put a positive in front of there so that I don't forget it's a positive 1. I have positive 2x, I have minus 4, or negative 4, and positive 2x. Start with 1. There's 2x. 1, 2, 3, 4 negatives, negative 4, and then 1, 2, positive 2x. So I'm going to draw it out. 1 and 2x and negative 4 and 2x. I'm going to make a 0 pair with those and remove them. Cancel out a pair of them. And then I'm just going to move these over so they're all together. So what do I see? I see 4x and negative 3. So I could write that in 2 ways. I could write it as 4x minus 3, or if I just change the order, like that, right? It's the same thing as negative 3 plus 4x. So if you got either of those, that's correct. It doesn't matter which order, as long as you have the signs in front of it, because remember there's an imaginary positive in front of that 4x as well. Okay, and now on to the challenge. Whoa, so many terms. So many terms. Whoa, paper's falling. All right, we have so many terms, but we can take care of it because we can just figure out which ones are variable terms, which ones are constant terms, no biggie. Negative 3 and positive 4y and positive 5 and negative 2y and positive 2 and positive 3y. So I'm just going to do it exactly as it's set up here, and then I can start putting together things that are alike. 1, 2, 3 negatives is my negative 3. Positive 4y. 1, 2, 3, 4. Looks good. Positive 5. Thankfully, I've got a nickel here. Negative 2y, or the opposite of 2y. 1, 2. Positive 2. 1, 2. And positive 3y. 1, 2, 3. Okay? So that's what it actually looks like. Now, this is so much stuff that what I like to do before I find my 0 pairs is I want to put all the things that look alike together. So in this case, I'm going to put all my variables, or all my pasta, together. And then I'm going to put all my money together. Again, it doesn't matter which way you do it. I'm moving my money because it's easier. And I put all the money over here. And then I have all my pasta together. And I can start taking away 0 pairs now. I can take away 1 0 pair, 1 0 pair, and then I'm trading out 1, 2, 3, 4, 5. Okay, 5 pennies for a nickel, and now I can take away 1 more 0 pair. So I'm left with a positive 4. Over here, I've got lots of pasta. I end up having 1, 2, 3, 4, 5, 6, 7 positive y and 2 negatives, 2 negative y. So I can take 1 0 pair away, 1 0 pair away, which makes sense because 7 minus 2 is 5. So when we look at those coefficients, it works. So this is actually equal to 4 plus 5y, or it's equal to 5y plus 4. We can switch the order because we're connecting them with those addition signs. If you want to see that in another way, we can look and identify our variable terms. I know that positive 4 and negative 2 is positive 2, and another positive 3 is positive 5. So combining the coefficients gives me positive 5, and that's why I know this is positive 5y. And then my constant terms, negative 3 and positive 5 is a positive 2, and a positive 2 and a positive 2 is a 4. So that's where it comes from. All right, the last problem. Again, I'm going to start by splitting my terms up so that they're easy for me to model. And I have negative 2f, 1, 2 negative bow ties, positive 8, 5, 6, 7, 8, positive 6f, 1, 2, 3, 4, 5, 6. So much pasta! It's almost a meal. Too bad it's not cooked yet. Negative 3, 1, 2, 3 that are negative. Negative f, flip that one over so we can see that negative. And then positive 6, 5, 6. You can see I'm running out of space when I try to space them out. Thankfully, if I put all the money together and all the pasta together, that'll make my life easier, and it'll also make the math easier. All right, so I've put all my money on one side, put all my pasta on the other. I can see really quickly, and you don't have to do it one at a time. You can do it as many as you see at a time. I see 3 0 pairs already paired up. So I can take all 3 0 pairs away at one time, and I'm left with just 3f. Over here again, I can take away as many 0 pairs as I can pair up together. I can do it at once. So I see 3 0 pairs paired up, I can take them away, and I'm left with 11. So my answer here is 3f plus 11, or 11 plus 3f. You can write it either way because in addition, you can change the order through the commutative property. All right, hope that helped. And next time I'll see you to solve two-step equations.